Thanks everyone for joining my talk about, as it's written, no YAML. So that's going to be interesting, and I'm happy that at least some people are also interested to say what's this all about no YAML, because hey, we learned YAML is the language for everything around Kubernetes. Quickly to my person, maybe some of you don't know me. So my name is Engin Diri. I'm working at Pulumi as a customer experience architect. I'm from Germany, as you can hear, so sorry, not a native English speaker. I like Kubernetes. Actually, I'm really crazy about Kubernetes, so that's one of my things I prefer. Cloud transformation, that's what I work mostly in my former place, and also currently at Pulumi. That's what I do, helping customers to tackle the challenges, to get their workload on cloud, or to handle the whole madness of cloud. And yes, continuous everything. I also put my socials down there, so feel free to follow me on X or on LinkedIn, Mastodon and everything. So you see that thing become bigger and bigger because everything has to be tackled. Okay, so that's about me. Let's dig into the actual talk. So, what happens if I told you that you don't need YAML to deploy to Kubernetes? So probably you will be like, why? Why should I avoid this? Because hey, YAML, it's all about what we learned. I mean, when I do a CKA, for example, or CKAD, the first thing I learned not only about the CLI, but also to edit and to create a YAML file. So what's the deal about this? And here comes my question to you. What are your thoughts about this? Why you should avoid YAML? What are the things you experience? So feel free to give some feedbacks about your experience. And I'm sure, Ramirez, you have some feedback around this. Do you like YAML?
I do like YAML, but it's not meant for humans.
It's not meant for humans.
It's just hard and error prone, and there's no compiler. It's just really hard.
Yeah. Anybody else has some experience? Yeah.
I don't like that YAML is, like I was saying earlier, it's not really canonical. Like there's too many ways of doing the same thing in YAML, or rather, its relationship with JSON is not always what you expect it to do. Like no being false is kind of a crazy aspect of YAML. Yes and no shouldn't be true or false.
Absolutely. I agree completely on your points. And I brought some points. And again, this is just my interpretation. I'm sure maybe you disagree on the points. So why we should avoid YAML. So these are my points. For me, for example, and this is also something we saw when working with customers and also with my colleagues in my former place, it's just the lack of programmatic control, which is really sometimes painful. I mean, later, Azure DevOps, for example, Azure DevOps pipelines, they introduced now some kind of programming elements inside the YAML. It becomes really crazy. So getting a simple thing like a loop up and running without using some stuff from the ecosystem like queue and so on becomes really, really crazy, and your YAML file can really become also very complicated. So for me, the simple thing of programmatic controls is something I don't like. Another point is, and now again we talk here about vanilla YAML and not leveraging some tools from the ecosystem, is also the lack of code reusability. So you can end up to have keeping all the time the same boilerplate code. Okay, I have to speak louder. So that's one of the points. Of course, as a developer or somebody with a development background, it's also no debugging capabilities. So this is also a point I don't like very much about a vanilla YAML approach. Also the limited ability to test for example, we talk here about the Kubernetes context to say, okay, I write a Kubernetes deployment in YAML. How can I test it without leveraging some kind of tools from the ecosystem? Also a very point. And now comes also, and this is my experience working with developers in different companies, is also the lack of developer familiarity. So people have really to understand, for example, in a Kubernetes manifest, how the YAML is built up, how a deployment is set up. So there is no really guidance, no help. I need to know, for example, this is a string, this is a number. So here comes the points. And this leads directly to the next point, no type safety. That's also one of the points, and that's again, my point. And if you try to mitigate some of the points, you mostly end up something like this, where you have some kind of templating engine in between, be it Ginger, be it here the Go templating, or whatever you have to give more flexibility. So everybody know Helm. You've probably been to the talk of the history of Helm. Nothing wrong with Helm, but things can become quite complicated. And then you come into the point where you have bugs inside. Some little intention can really screw up your stuff. And I get feedback also from other persons who said, yeah, we had an issue when deploying. There was an intent error, and we just discovered before we deployed to production. And this is really, really painful. So, but don't believe what I'm saying. So let's ask our how do you say this in English? Our journalists on the street, and what are other people think about this? So is Engin making stuff up, because he works for Pulumi, he wants to try his programmatic approach? No, I went through Twitter and I just typed YAML and to see, okay, what are people writing? And some of the things which is written are really, really interesting. I fucking hate YAML. So these are the points. Another one is also here, YAML is the worst. And there's the next one. And this was a recent one, and I also put this on the list. I saw recently cited, you wake up, you're the last person. He said, I declare victory against YAML. So that's the thing. So I'm not the only one who has a problem with YAML. But then again, so what are the possible solutions? Okay, we opened now the problem space. Yeah, okay, there is something going on. So what are the possibilities? So let's see. What I suggest here is to say, use a generic programming language instead. What are the benefits of a generic programming language? We can apply now our software engineering best practices, because somehow we use programming language to create our business logic. So we have a tool chain already in place. We already have maybe an internal chapter or tribe. We thought about this, what is good code, and how to adhere to the principles like dry, don't repeat yourself, or KISS, keep it, we talked about this, KISS, it's a thing I keep on repeating, keep it simple and stupid. So that's a thing. And the last one was the Yagni principle, you're not going to need this. So these are all things we follow. There's also a book called Clean Code, so there are really, really thoughts about this. We reduce the cognitive load. So sometimes we are now in a situation where everybody is a 200 times engineer. So we expect now everything. We expect that developers also take care maybe of parts of the infrastructure. Management loves to throw out stuff like you build it, you own it, or you build it, you run it. So we come in a situation where we have to think about, hey, I'm not only in charge of creating the logic of fulfilling what my business needs, I'm now also in charge to deliver it. Maybe to prod even, maybe just to a pre-stage, maybe I'm in charge to define the resource limits and everything, because hey, I know this, it's my thing. Yes, I could throw it to somebody, I could talk with somebody, maybe I'm in the luxury situation that I have an operation person embedded in my team, but still you come in the place and then you think about this to say, okay, do I need to learn now something new? Do I need to learn a whole ecosystem just to create my deployment, or can I reuse what I already have? I have my IDE, I have my ZonaCube, I have all the value chain already in place. So why not use it also here in this context for Kubernetes deployments? Next point, yes, type safety. Type safety here is very good because I get, and now comes a phrase probably reused so often from marketing side, shift left. Yeah, but type safety for this is shift left. I see the issue directly when I create my stuff because I get the wiggly lines. So the wiggly lines are the thing where I get instant feedback to say, hey, there's something wrong. Or I try to put a list where actually there's an object and so on. So I run onto this always when I'm working. So type safety, very, very good. again, error handling. Now I can start to make also shift left approaches. I can make sensible error handling here. I can capture situations and do proper stuff with it, which I maybe not able to do when I'm not using, for example, a programming language. So these are some of my points. And again, a question on you, because I would like to know more about your experience. What do you think I miss on this list? Is there something you say, yeah, fine, but there's another big bonus using a generic programming language? Yeah.
Italicized, but it's type safe to
Yeah, absolutely, yeah.
like NPM packages.
Yes, you mean sharing with other persons what you created. Absolutely, this is also part of the demo I have. I can create now, in my programming language, maybe an abstraction layer. I can say, okay, I created now an object which describes the perfect web deployment of Kubernetes with services, with service accounts and so on. And now I can use Artifactory to distribute this and say, hey, you don't need to do this anymore. You can just use, for example, this abstraction I created for you. Absolutely. Anybody? So this is part of the solution space. So what options do we have? So I looked around and said, okay, what is outside there? And again, I tried to get some elements out of it to say, okay, what is actually on the market? And I'm sure there are some other projects lying, floating around. So we have CDK8s. So the people around, maybe it's not the opportunity situation now, say Terraform currently, but actually they have also a project where they have a programmatic approach. So you can send down, you can write the deployment also for Kubernetes with the Kubernetes provider and then just spit out your Terraform file. We have YAML, we have of course Pulumi, we have Isopod, which is a Starluck approach to create in Python your deployments, JS policy, which goes to the admission controller, and so on and so on. So CDK8s, there are solutions for this. So now we come to situations, okay, there are many, many choices. So Engin, can you show us 3 options in a little bit more detail? And sorry, maybe you already tried one of these. So I picked 3 of them. And I want to show you some of the benefits of the 3 and give you some ideas. And maybe when you come back at your workplace or at home to say, okay, maybe it's an option. Maybe I have currently a pain and maybe it's a situation to try out if it solves the pain. So first of all, again, the talk is all about Kubernetes. So I focused on the tools which are able to do Kubernetes CDK8s. So CDK8s supports TypeScript, Python, Java. There's missing a comma. I said I'm not a native speaker and looks like I have issues in grammar also. Java, very interesting to have Java support because we have still a huge amount of people who develop in Java, and everybody coming from the finance area will know that Java is a language which dominant. I still get from headhunters, I did Java before, they contact me to work in Switzerland on a project with Java. I didn't work since years actively in Java, but it helps to leverage your existing developer community in your place who maybe know Java, and with all the things going about Graal, VMs and Quarkus, for example, I think it makes really sense to have the opportunity. CDK8s also offers the CDK8s Plus library. I found this very interesting. These are high-level constructs already created from the community. So you get, for example, if you say, I want to do a deployment, you get the possibility to fill out some of the properties of the deployment, and stuff you let out, for example, pod security context and everything will be automatically filled out from this construct. So people already created a nice opinionated deployment, and you can just override the values, which is very, very useful. So you have already some abstractions, some constructs here. Everybody who worked with the AWS SDK knows the principle of constructs, and you can just reuse them. We will see this because CDK8s is part of the demo, how it looks like in action. And now there comes a controversy part to say, Helm, wait a minute, you just say Helm sucks and now you put Helm support on the top of it. Yeah, because we don't want to get disconnected from the ecosystem. Because one of the things people say then is, do I need to rewrite this stuff? Oh, no, you don't want to take ownership of your Kubernetes stack deployment and so on. So it's good to have the possibility to use existing ecosystem to be connected to it while still working on your stuff, so on your own projects, on your own applications. So Helm support is for me very important, and CDK8s offers this, and I can use this and can deploy my Helm. And now you get the idea. The values for my values file, this is something I can now programmatically feed into this. So I'm not running around on a values.yaml file with some of the values I want to override. I can maybe fetch them from a database and so on, because everything is programmatically. Here comes another point I found also very interesting here from the CDK8s approach is the code will be synthesized into YAML back again. Again, like, hey, Engin, what are you talking, bringing the stuff back into YAML? Maybe your deploy chain is not fitted currently for this, or your operations team is not ready for this, and they say, I don't know TypeScript. Either you give us a YAML file or whatever delivered to a specific place, or you have a problem. So here in this case, I can write in a type-safe language, in a programming language, my deployment. I kick off the synthesize process, and it spits out a YAML. I can then pull requests somewhere. So I can now work together with other persons and say, hey, I do my part, and you are back again in the thing you are currently, because maybe you need to enable them. Maybe they are not so far in the journey, and nothing is more worse than alienating the people and say, hey, we want to use Go. And they're like, I don't know Go. And this is the reality also, that maybe some people in the company cannot program or are not able to do this or don't have the time. So this is a good compromise to say, working on stuff, getting the benefits of the programming language while not losing the other persons. And yeah, this is the QR code where you can look up the documentation and the project in more details. Option number 2, and you will see the ribbon and that I how do you say this, put away the colors, is because it's YAML, it's a project, and it has only Go support. The only thing you need to do is to implement a deployable interface. This is very handy. And you can convert existing YAMLs to Go. That's also a very interesting approach. Very quick, very easy. You can get your existing code into Go, so you're not losing what you already created, which is also very, very good. Here's the QR code for this. And the reason why I put it now under the color, it's made from Chris Nova, and maybe you followed the news and so on. She had an accident, a climbing accident, and I think 2 weeks or 3 weeks ago she passed away. So that's in memory to her. Last option I want to present to you is Pulumi. And here in Pulumi we have also the support for TypeScript, JavaScript, Python, .NET, Java and Go, so also a huge variation. .NET actually, every time .NET pops up, you can be sure that's all about Azure, so mostly the Azure people also are related a little bit to the .NET, so that's interesting. And the benefits of Java I just said, and Python and so on, that's something I expect. Pulumi offers also some additional libraries called the Automation API, where you can programmatically call Pulumi. So you could create a CLI, you could create a backend and so on, which can become handy if you think about including the program into existing projects you have in your place. I recently created a Backstage plugin. It's in TypeScript. That was very handy here. You have the option to create infrastructure also. So you're not only bound to Kubernetes, you could create the Kubernetes cluster and then continue to deploy your workload in the same cycle, which is very handy. You have the possibility to make a YAML import. Again, very useful if you not want to lose the work you already created here. That's very interesting. And the last point is also Helm support. I mean, I just mentioned before why I think Helm support is still important. And yeah, here's the code to scan this. and see more about the Pulumi approach. And yeah, maybe that's a little bit boring. I can imagine I keep on talking about this. So let's switch to some demo, and I try to be as quick as possible. And yeah, there will be now code, so everybody who's not who doesn't want to see me typing stuff, that's the moment you could leave. Quickly for the demo, what I want to achieve. So I want to deploy an Nginx, and the Nginx should deliver hello Civo navigate when I deploy this. It should consist of a service, a config map, and a deployment. So this is, I think, quite basic. I'm going to use CDK8s and Pulumi to show you two different approaches. As a language, I chose Go because I like Go. I could also choose something else, but then here in this case, it's going to be the Go. And I'm going to deploy it to a Docker desktop to avoid any latencies with the network. So, saying that, let me quickly change my settings. System preference and click on mirroring. So, okay, that's perfect. So, that's the wrong one. Okay. Let's start, randomly start with the Pulumi approach. So I will zoom this also up so we can see everything. So to get Pulumi up and running, of course, you have to download the Pulumi CLI. You have to create a Pulumi template with using Pulumi new. So this is something you have to do a little bit of scaffold. You get then a little boilerplate code where you can start to build your actual deployment. And this is the part I will show now here. So let me go to the appearance, go to distraction-free mode, and then we go to the presentation mode. So the whole magic here starts then with the Pulumi run function. So I can start now, and what I will do now, because I don't want to type now everything, is just to deactivate some of the parts. So I just wanted to show here with the app labels, you can just define stuff, you can reuse stuff, you can, here in this case, I wanted to say, okay, I have a label. Everybody who used Kubernetes know that the labels is very important, so it's the pod selector and so on. So it appears on several places. We just talked about dry, so I put it here somewhere, and then I can change it here when something happens. I could create a function out of it and say, okay, I reuse the deployment service config stuff for different deployments. So I think everybody who programmed knows what possibilities you have. Second part is now creating the config map. So here we can see that I initiate a new object here from the type of config map. I can then define the metadata. Again, Kubernetes, so I give it a name, the config map, here called Hello World config map, and it consists of a data area. And here I can put now the Nginx config inside. Also not something new here. So we head over to our deployment part. So here I define now the deployment. Again, I put now the stuff I found interesting inside. Of course, you could also say, okay, I don't need this part. This is some stuff I put in. Like the strategy and so on, and here you can see the template. I could also take out some of the parts, for example, the pod template spec, and put it into a function, and then I can reduce also here the verbosity of it, and could keep on reusing the templating part with different properties. So I think you got the idea where we're going. I defined the volume mounts, and here we can see I define the volume. So it really resembles our Kubernetes manifest, but here I can see everything is type saved. I know what to use. I get my, let me go here. Normally I should, and this is the thing in a demo, why it doesn't work. Okay, normally it should give me Yeah, it should give. Okay, whatever. So, create everything. I create also the service, and you can see here now I can use one of the objects I create before as an input for the next one. So I can say, hey, use the name from one, get the port of the one, and feed it here into the service. I create here the service. Here we see the app label, and I put also a little dependency structure into it, because sometimes you have the case where you say, hey, I need this to be deployed before I need I deploy the second one. So here in the case you can explicitly send a dependency. Normally Pulumi also calculates the dependency structure and say, okay, this resource doesn't have a dependency to any other resource, so I can just deploy it independently. And that's here. So let's go back and deploy this. So we exit the presentation mode and do the distraction-free mode. And we go to the Pulumi Hello World. And then I can preview the stuff. I can say, okay, let's give it oh, wait, okay, that's my fault now, that's on me. Okay, so normally I just made it like this, and then these are the libraries I just import. Okay, now everything is here, and then what I mentioned before, I can see now here which type spec is, so I get the information, I get my IntelliSense, what some of you mentioned, so I get all the informations. And if I now say Pulumi preview, and we say here a dev stack, again, there are different stacks. I see what gets now created. In this case, yeah, this is the infrastructure which gets deployed. And if I say Pulumi up, it should deploy, but wait, before I do this, because let's have a look into our cluster. There's nothing deployed. So no pods for this use case is deployed. And if we say now Pulumi up, it should deploy everything. Okay, we see the config map is deployed. We can see that the deployment and now the service. There are also some conditions, which is nice. So the Pulumi deployment can see if the deployment is up and running and is serving, and then it continues. I get quickly an error message here. And let us look into our K9s. Yes, it's deployed, and as a good Kubernetes user, I deployed it in the default namespace. And when we look into our service, yep, service is also in start. So when we say curl localhost, we get our hello world. Yes, here's our hello world. Perfectly. So destroy the stuff, and then we can head over to the CDK8s part. Okay, everything is nicely gone. Fine. So now have a look into the CDK8s part. Again, you need to install via npm. You need to install the CDK8s library. This is the CLI. That's one part, and then you have different methods to work on this. Here in this case, we're going to use CDK8s synth to create our manifest in the dist folder. And the import part I already did, so we see here, let's make this bigger. I import here the Kubernetes library, so this is everything set up. I define, okay, my language is Go, this is here the definition. And when we look into the code, and we make this again big, distraction free, and presentation mode. Again, it will generate like this completely, as it's not completely empty. You get here the little boilerplate code again to say here the chart structure, and then you can also start to type your code. Similar to the Pulumi approach, we have again here the config map. I could go in CDK8s also on a very low level on config map, but as you can see, I already started to use the construct, the CDK8s plus, here in this case, the version 27. So for every Kubernetes version, there's also a corresponding construct library. And as you can see now, I just say new config map, because it's a construct which does everything in the back, metadata and so on. And here I just say config add data. And then similar to the Pulumi example, I just write down my the content. Here we see we want to create now a volume from the config map. So I use from the construct the volume from config map. I give here the items in. So I say engine X config should be the key and then the content of this. And now I create a deployment. And this is what I said with the constructs. I just attach now the volume. So I define the volume here. I just add the volume. So this construct gives me many points to work on. I define the container, the mount. And now the exposing of the secret is via expose via service, not secret of the deployment. So I just call deployment.expose via service, and it will create for me also the service. Okay, so let's leave this one. I think we're getting exit. We are soon finished. So appearance, exit. So go back. Okay, and then we go in the CDK8s folder, and then we say where CDK8 synth. Okay, and now he created a dist folder, and this is now where the magic happens. As you can see now, he created the config map, very nice. He created a deployment, and as you can see, he also, because it uses an abstraction for us created, he also filled out most of the properties. So we get here the strategy. This is not a mandatory field in Kubernetes. Here, rolling update, it's always the default, but he filled out the stuff. And we see we get the security context. So people using this construct, not forgetting about this, they will automatically inject it. If I want to overwrite it, I can explicitly overwrite it, then doing a pull request, somebody review it and say, well, wait a minute, you want to start it as a root container. I get the probes and so on, so everything is set up. The service you saw was a one-liner. It will create the service here. And when we deploy this also, this is quite easy. So we can say kubectl apply -f dist. So yeah, you could use a customize or whatever if you want. The team wants to create something around this. And let's have a look if this is also working. Yeah, we see that it's also deployed. Let's have a look into the service. The service is deployed. The deployment itself is also there. And when we make a curl against localhost, we also get our hello Civo navigate. So switch back to our slide. Okay, it's time for wrap up. So let me play from current slide. Okay, wrap up time. What did we learn now? We saw that YAML is not the first choice. You have other choice depending on your needs, on your pain you have. It could be viable to just look around and say, do we opt automatically always for YAML, or is there a possibility to maybe use a different approach? So as you see, there are approaches outside, and you can choose your programming language of your choice, of your skill set, and some of the options even offer the opportunity to still maybe deploy on a way your operations team are used to this, so you're not very invasive. You can slowly introduce the change into the company and maybe switch then completely to our only approach of using a programming language, and you are not disconnected from the ecosystem, so you're not losing anything. Yeah, and that's it. Thanks a lot. That's a joke. You can ask me, honestly. That's a joke. My colleague is here, and he's like, hey, says to my boss, Engin doesn't want questions. So anybody, yeah.
My organization here in Azure, and at the moment we're looking at implementing Terraform,
Mm-hmm.
but we know we haven't Terraform. How well does Pulumi play with Azure Resource Manager in terms of, does it do everything that you can do in ARM templates?
That's absolutely a good question, and short answer is yes. It does. So now you can say, Engin, are you not biased? Because you work for Pulumi. No, it does. We have different providers. I would welcome you because Daniel is sitting here in front, who's also working as an engineer in the Azure provider. So maybe we just catch up later on and we can talk a little bit deeper into the support from Pulumi for Azure deployments. But yes, it does. It does also Kubernetes. So that's yes.
Can you have types saved with CRDs?
Yes, you can create, we have a CRD. I mean, now I talk about Pulumi only, sorry. Pulumi has the option that you can define your CRDs also. So one of my things I thought about was also, I did a how do you say this, a blog article about the admission controllers, the new one with the 126, and there you have to create a custom resource, and I could do this easily in Pulumi, so that was quite handy to write your CRD definition in here now in this case only for Pulumi. I didn't look for the other ones, I'm sorry. That was partly work related, so that's why I looked it up in Pulumi. I think there was another question. Ah, yeah, you.
Yeah, I have a question. One of the biggest challenges with YAML for me is also the lack of flow control. Like you create templates and then you trust on Helm or any other thing to do for you. Do you think that's something that you see these tools getting into that, like giving us more control over especially when you need to do deployment, you're like, okay, wait for this to happen before you do this or do something about it. Is that something you see Pulumi and CDK8s or others providing, or are we still going to be in this world of declarative?
What do you mean with flow? Again, help me.
Like, for instance, controlling the order of things that are created or having weights between, when you're moving, especially with legacy services, sometimes creating everything at the same time doesn't really work. And with Helm, with Kubernetes, it's impossible to do things like, one deployment, and once it's ready, create the next one.
Yeah.
That sort of thing.
Yes, I mean, of course, with a programming language, it helps you, gives you a thing. I know that, for example, in Flux or in Argo, you have sync waves, you can set depends on and so on to give things in structure. You can still make a lookup to delay maybe the deployment of the next one. Here in a programming language, yes, of course, you can wait for a specific condition and then continue, you wait for the output. You just go back to the cluster and say, are you deployed? Are you healthy deployed? And so on. Yeah, some of the orchestration work you can bring down. The Pulumi, for example, they offer an automation API, so this programmatical approach to call different stacks, and then you get the freedom. So yes, of course, there are the benefits of using this, which makes life a little bit easier. And that's what I try to explain also. Look at your use case, look at your pains, and then decide, because we choose, as engineers, we choose tools depending on our pain and so on. I know that sometimes people get very passionate about whatever and they get Stockholm and defend whatever. I'm always a person to say, okay, I have a specific pain. This tool doesn't cut it anymore. So what can I do now? Either I file my tickets, help to enhance this, or I have to look around because I get paid to solve problems and to help my business and not work around some conditions or create thousands of bash scripts or whatever just to overcome a specific case and shell out into a CLI to come back again to do my Helm stuff, Helm patch or whatever. So yeah, that's a thing. Okay, then thanks again for joining my talk, and yeah, have a nice evening.